Hi, this video covers the data collection for analysis of vinegar in Chemistry 102. The first thing we're going to do is measure out 15 milliliter aliquots, that's just 15 milliliter samples of the HCl. So we're going to use this HCl to figure out the concentration of some sodium hydroxide. So we know the concentration of the HCl. We're going to figure it out for the sodium hydroxide in the first part of the experiment. So this involves using a volumetric pipette. This is a 15 milliliter volumetric pipette, and we're going to use it to measure out 15 milliliters. First thing I'm going to do is I'm going to rinse the pipette out a little bit. So just pull up a little bit of liquid in there, sort of swirl it around a little bit, and then I'm going to put it into a waste container over here. So that just kind of makes sure that there's, if this was wet, we'd be changing the liquid in there out for other things, for the acid solution. So now what I want to do is, if we can see right underneath my finger, there is a little line. And to deliver 15 milliliters from this volumetric flask or volumetric pipette, you fill it up to that, so the bottom of the meniscus is right on that line, and then when you let it drain out, it will deliver 15 milliliters. So to fill it, I take this thing, it's called a pipette bulb, and you push it down, you depress it, and then you hold it against the top and let it, and then slowly let the bulb out, and it will pull liquid up into the burette, or the pipette, excuse me. And so we're going to keep going and keep going and keep going. And I'm going to do it till it comes up a little bit above the line that I'm thinking of. And then I'm going to let go and put my finger over it. So the line I want to fill to is right here, but the liquid right now is up there. So I'm going to lift my finger and let it flow down. So let me get down here so I can see it a little easier. I'm going to drain it out. There we are. And then I'm going to drain it into a flask with a label on it. It takes a little while for it to drain out, but you just wait until you don't see any drops coming off the end of the pipette for about 5 seconds. If there's one last drop hanging on the outside, usually touch the tip of the pipette to the side of the flask, and that will sort of, the drop will leave the end of the pipette and go onto the container. So they're like 1, 2, 3, 4, 5. I don't see any drops in those 5 seconds, so we're all set. I'm also going to add 15 milliliters of water, and we don't have to be real precise about how much water goes in, because the water doesn't affect the acid-base titration. Because it's neutral, it should be not have any effect. We just add it to kind of, what it does is it makes a larger volume down here so that we can sort of get better mixing of the acid and the base. So there's 15 milliliters of water. And then finally I'm going to add 4 or 5 drops of phenolphthalein. So we got 1, 2, 3, 4, 5. There's 5 drops of phenolphthalein. So that's one of 3 HCl samples I'm going to make. I'll make the other 2 right now. I did want to show you one thing in case, I'm sure it's been shown in other videos, but here I just wanted to stress it again. So in our laboratories, at each sink there are 2 taps. One of them, this one here with both a hot and a cold handle, that's city water. And so there's there's impurities in there, particularly ions, and when you turn these on, they just run like a normal sink. On the right hand side, there is another tap which just has one handle, and if we can see over here, it says DW, for that's deionized water, and deionized water has been gone through a process that removed many of the ions, and it gets used to, when you turn it on, it only stays on as long as I hold on to the handle. I'm using deionized water for diluting the samples and to rinse things out. I need some, so I'm going to put this here and just fill it up a little bit. There we are. So remember, sometimes it's really helpful to use deionized water in your analysis. So the burette has been filled, and if you can, I'm sorry, sometimes it's hard to see, but you can see right up there that it's filled right about to there. You'll be provided with images showing the beginning and final endpoint. And so down here is one of the HCl samples with water and phenolphthalein. We can open up the burette, and I'll just sort of slow it down a little bit. Maybe go a little faster. At the start, you can go kind of fast if you might be noticing there, it's starting to form it's starting to get a little bit of a pink color. So I want to stir and watch, and I want to add just enough sodium hydroxide so that a pink color remains. This is a little slow, I'll go a little faster. So the pink color is still showing up, but it goes away as I stir. It takes a little bit longer each time. So you can see that there's just a little bit of color there. I want to wash down just a moment. Let me pause this. I wanted to get a water bottle. We can wash down the sides of the container just in case there's any. This is just water I'm adding, and the idea is that if there's some base or acid on the walls, we're washing it down into the mixture. And we can add a little bit more. You can see it's going real quick. Changing that right now. I'm just adding single drops, about 1 drop a second. Whoop. I had a little bit more than I wanted to there. When I had just 1 drop. I think I added 2. That looks not quite. Just 2 little drops. There we are. And there's the end. So I'm going to take a picture of the final burette reading. This is the first of 3 samples, and I'll do the titrations for the other 2 hydrochloric acid samples. Just to wrap up the data collection for the analysis of vinegar, I've made 3 samples with 15 milliliters of the vinegar unknown, 15 milliliters of deionized water, and a few drops of phenolphthalein. So I'm going to titrate with the sodium hydroxide in this burette. One thing I didn't point out, and I would like to, it's the fact that these 3 samples are all 15 milliliters of unknown vinegar. Therefore, they should take about the same amount of sodium hydroxide to neutralize that amount of vinegar. So the first trial you need to go a little bit slower, but the second and third trials, you know pretty closely how much sodium hydroxide is required to neutralize the vinegar. Therefore, you can sort of quickly let out maybe up to about 1 or 2 milliliters less than the first sample, and when you get to that point, about 1.5 to 2 milliliters away from the amount used in the first trial, then you can slow down and really watch for the color change. That'll speed up analysis quite a bit. At least I should say a little bit. All right, so I'm just going to do these last 3 titrations, and all the data will be collected for analysis of vinegar. Good luck.